In the span of 72 hours, Madagascar lost more than buildings. It lost its future. February 10th, 2026. Cyclone. Gazani's 250 miles per hour gusts did not just flatten Toamasina, they obliterated the economic lifeline connecting an entire island nation to the world. 80% of the city is gone. The port that handles millions of tons of cargo each year is now a tangle of twisted metal and debris floating in the Indian Ocean. And yet what happened next made disaster experts realise this was not just about Madagascar anymore. Scientists studying satellite data discovered something chilling. The twin cyclone strikes were not a coincidence. They were part of a feedback loop that is now accelerating across the entire Indian Ocean basin. Each storm fed energy into the next. Each strike weakened the systems that normally protect entire regions from cascade failures. 16,000 people were displaced. 400,000 people were facing starvation. Supply chains were snapping from Africa to Asia. But here is the question keeping climate researchers awake tonight. If back-to-back cyclones can shatter a nation in 10 days, what happens when the pattern spreads to other ocean basins? And how many more dominoes are already wobbling, waiting for the next coordinated strike? At first, scientists thought the devastation in Madagascar was a tragic coincidence. But this was not random weather chaos. This was coordination on a scale we have never seen before. It was not just Madagascar that felt the impact. The entire Indian Ocean basin was affected. The 10-day window between strikes was produced by atmospheric conditions. Cyclone Fitia weakened the island's defences, setting the stage for Gazani's knockout blow. But what came next shifted the entire conversation about extreme weather. Here is what made meteorologists realise we are entering uncharted territory. Satellite data from the European Weather Centre revealed pressure systems sharing energy between storm formations. Temperature anomalies indicated coordinated heat exchange. Energy transfer patterns through the Mozambique Channel painted a chilling picture of connected storms. For the first time, scientists pointed to actual atmospheric communication. Dr. Sarah Chen at the MIT Climate Lab said that scientists are seeing storm systems share rotational energy like binary stars, and that the data shows something they never thought possible: weather learning to coordinate. And it is not just Madagascar. Similar synchronization was detected in the 2025 Australian cyclone season. Atlantic hurricane pairing events have increased 300% since 2020. Pacific typhoon clusters are showing energy-sharing behaviour. The implications are staggering. If storms can learn to hunt in packs, no coastline is safe, no infrastructure is resilient enough, no disaster response plan is adequate. We are entering an age where the worst-case scenario is just the beginning. To understand why Madagascar was so vulnerable, we need to look at its geography. The island sits right in the southwest Indian Ocean cyclone corridor. From November to March, an average of 2 to 3 tropical cyclones slam into Madagascar every year. Dr. Fabrice Chauvin of Météo France, La Réunion explains that Madagascar's elongated shape creates a target zone about 1,600 kilometers long for cyclones. The island's topography, with coastal plains and a mountainous interior, creates a natural funnel for storm surge and flooding. Madagascar has faced devastating cyclones before. In 1994, Cyclone Geralda killed 200 people, setting a tragic baseline for worst-case scenarios. A decade later, Cyclone Gafilo claimed 350 lives, exposing critical gaps in infrastructure resilience. In recent years, the pace and intensity of cyclones has only increased. Belna struck in 2020 and Batsirai in 2022. Each storm revealed new vulnerabilities in Madagascar's defences. Toamasina, the port city that bore the brunt of Cyclone Gazani's fury, handles 80% of Madagascar's international trade. Professor Jean-Paul Padiou of the University of Antananarivo warns that Toamasina is a single point of failure in Madagascar's economic system. With over 300,000 people living in the flood-prone coastal zone, the city was a catastrophe waiting to happen. The port's infrastructure was built to withstand Category 3 cyclones, with wind speeds up to 130 miles per hour. But Gazani was a Category 5 monster, with sustained winds of 160 miles per hour and gusts up to 250 miles per hour. The storm surge alone, reaching 6 meters in height, was enough to inundate the entire port complex. As the cyclone made landfall, the port's cranes toppled like dominoes. Container yards turned into debris fields. Fuel storage tanks ruptured, spilling thousands of gallons of oil into the Indian Ocean. The economic lifeline of an entire nation was shattered in a matter of hours. But the destruction of Toamasina's port was just the beginning. With the main gateway for imports and exports crippled, the cascading effects would soon be felt across the island. Food shortages loomed as shipments of rice, Madagascar's staple crop, were stranded offshore. Fuel supplies dwindled, causing power outages and transportation gridlock. Critical medical supplies, including insulin and antibiotics, were suddenly out of reach for millions of people. The twin cyclones did not just destroy infrastructure, they upended the delicate balance of an entire society, and as the world watched in horror, a chilling realization set in. Madagascar was just the first domino to fall. The last time the Indian Ocean witnessed coordinated storm attacks was 1994. Those storms were spread across months, not days. In February 1994, Cyclone Geralda hit northwestern Madagascar on the 2nd. As recovery efforts began and international aid mobilized, a new threat emerged. Cyclone Holanda formed on February 10th, threatening the southeastern coast. But unlike the Fitia and Gazani pattern, Geralda and Holanda remained independent systems on different trajectories. The 8-day gap between storms allowed for partial recovery. The different impact zones did not overwhelm a single infrastructure hub like Toamasina. Dr. Emmanuel Rindra Harisaona, a leading meteorologist in Madagascar, notes a crucial difference. He says Geralda and Holanda were separate systems. Fitia and Gazani shared energy signatures that we have never documented before. It was as if they were communicating and coordinating their attacks. The 1994 double strike claimed over 200 lives and left 40,000 homeless. But the damage was spread out, allowing for more targeted relief efforts. The ports of Toamasina, spared from a direct hit, could still function as a lifeline for the island. Fast forward to 2026, and the scenario is vastly different. Fitia and Gazani did not just strike within days of each other. They targeted the same region, the same city, the same critical infrastructure. It was a 1-2 punch designed to maximize destruction and cripple recovery efforts. As Dr. Rindra Harisaona puts it, in 1994 we faced two separate enemies. In 2026 we faced a coordinated assault. The implications are terrifying. If storms can learn from each other, adapt their tactics, and synchronize their attacks, our entire understanding of disaster preparedness becomes obsolete. We are not just dealing with more frequent or more intense cyclones. We are facing a new breed of threat, one that exploits our vulnerabilities with surgical precision. It is a sobering realization. The cyclones that ravaged Madagascar in 2026 were not a fluke. They were a harbinger of a new era, one where the rules of disaster management no longer apply. As the world grapples with this new reality, the question remains, how do we defend against an enemy that is always one step ahead? The air grows electric across northwestern Madagascar. January 31st, 2026. Cyclone Fitia slams into the Mahajanga region with winds of 150 miles per hour. 12 deaths, 31,000 displaced. But the critical detail is that Phithia weakened early warning systems and strained emergency response capacity. In the 10 days that followed, a cascade of vulnerabilities emerged. Relief supplies were concentrated in the northwest. Emergency shelters were at capacity. National disaster management resources were stretched thin. And with meteorological focus on Phithia recovery, there was limited monitoring capacity for new threats brewing in the Indian Ocean. February 10th, 11:47 p.m. Satellites detect rapid intensification 200 kilometers offshore. Cyclone Ghazani's eyewall takes direct aim at Toamasina. Gusts reach 250 miles per hour. Storm surge projections are 4 to 6 meters. The port infrastructure crumbles. Cranes topple. Container yards flood. 95% of the city loses electricity instantly. When the winds subside, the toll is staggering. 59 confirmed deaths. 16,428 displaced. 18,797 homes were destroyed completely. 51,760 homes were damaged or flooded. Economic damage exceeding $2.1 billion. Port operations suspended indefinitely. But the numbers do not tell the full story. Behind every statistic is a human tragedy. Families torn apart, livelihoods shattered, communities erased from the map. In the aftermath of Ghazani, aid workers struggle to reach the hardest hit areas. Roads are impassable, blocked by debris and floodwaters. Bridges are washed away, cutting off entire villages. The few helicopters available are overwhelmed, unable to keep pace with the scale of the disaster. In Toamasina, the once bustling port city is a ghost town. The streets are deserted, save for the occasional military patrol. The stench of rotting fish and sewage hangs in the air, a grim reminder of the destruction wrought by the cyclone. At the port, soldiers and volunteers work around the clock to clear the debris. Progress is slow. The twisted remains of cranes and containers are a daunting obstacle, a testament to the cyclone's fury. As the days turn into weeks, the true cost of the disaster becomes clear. With the port out of commission, the island's economy grinds to a halt. Factories close their doors, unable to import raw materials or export finished goods. Unemployment soars as businesses lay off workers en masse. In the countryside, small-scale farmers, the backbone of Madagascar's agriculture sector, face ruin. Their crops, battered by the cyclones, are a total loss. Without access to markets, they have no way to sell what little they have left. The twin cyclones have set Madagascar back decades. The road to recovery will be long and arduous, a test of the nation's resilience and resolve. But even as the island begins to rebuild, a new threat looms on the horizon. In the weeks following the Madagascar double strike, scientists poring over satellite data make a chilling discovery. The twin cyclones were not a coincidence. They were part of a larger pattern, a new breed of threat that has been quietly gathering strength in the world's oceans. Dr. Toshiro Nakamura, a leading expert on cyclone formation at the Japan Meteorological Agency, is the first to sound the alarm. He says they have been tracking unusual energy transfer patterns in the Indian Ocean for the past few years, but the Madagascar event is the first time they have seen this level of synchronization between two major cyclones. Nakamura's team, using advanced modelling techniques, has uncovered a disturbing trend. The warming of the oceans, driven by climate change, is creating new pathways for cyclones to interact. Instead of dissipating over land or petering out in cooler waters, the storms are now able to sustain themselves by sharing energy across vast distances. Nakamura says it is like a feedback loop. One cyclone feeds off the heat and moisture of another, growing stronger in the process. As the storms intensify, they create even more favourable conditions for the next one to form. The implications are staggering. If cyclones can synchronize their attacks, no coastline is safe. The traditional barriers that have protected communities for centuries, distance, geography, and time, are no longer enough. Dr. Amanda Singh, a climate scientist at the University of the South Pacific, puts it bluntly. We are entering uncharted territory. The old rules no longer apply. Singh's research, focused on the small island nations of the Pacific, paints a grim picture. These communities are already on the front lines of climate change. Rising sea levels, coral bleaching, saltwater intrusion, they are dealing with existential threats on a daily basis. And now, with the prospect of synchronized cyclones, the risks are amplified exponentially. The Pacific Islands, like Madagascar, are particularly vulnerable to the new breed of storms. Their economies depend heavily on tourism and agriculture, sectors that are easily disrupted by natural disasters. With limited resources and infrastructure, they have little capacity to absorb the shock of a major cyclone, let alone two or more striking in rapid succession. Singh warns it is a ticking time bomb. Unless we take urgent action to address the root causes of climate change, we will see more Madagascar-style disasters in the years to come. The toll on human lives and livelihoods will be incalculable. In the face of this new threat, the world's defences are woefully inadequate. The traditional tools of disaster management, early warning systems, evacuation plans, emergency stockpiles are no match for the fury of synchronized cyclones. In Madagascar, the failure of the island's defences was laid bare by the twin strikes of Fitia and Gazani. Despite years of investment in disaster preparedness, the country was caught flat-footed by the sheer scale and intensity of the storms. The early warning systems designed to give communities advance notice of an impending cyclone were overwhelmed by the rapid intensification of Gazani. The storm went from Category 1 to Category 5 in just 24 hours, leaving little time for evacuation orders to be issued. Even if orders had been given, the island's infrastructure was ill-equipped to handle a mass exodus. The roads, many unpaved and poorly maintained, quickly became impassable, choked with debris and floodwaters. The few shelters that existed were quickly overwhelmed, forcing thousands to seek refuge in makeshift camps or on higher ground. The failure of Madagascar's defences is a stark reminder of the challenges facing countries around the world as they grapple with the new reality of synchronised cyclones. From the low-lying deltas of Bangladesh to the hurricane-prone coastlines of the United States, communities are scrambling to adapt to a threat that defies conventional wisdom. In Bangladesh, where cyclones have claimed countless lives over the years, the government invested heavily in a network of cyclone shelters designed to provide a safe haven for communities in the path of a storm. But with the prospect of multiple cyclones striking in rapid succession, the shelters are no longer enough. We need to rethink our entire approach to disaster management, says Dr. Salim Al-Hook, Director of the International Centre for Climate Change and Development in Dhaka. The old model, based on the assumption of a single isolated event, is no longer valid. We need to plan for multiple overlapping disasters, with all the complexity and chaos that entails. In the United States, where hurricanes are a fact of life for millions of coastal residents, the challenges are no less daunting. The country's aging infrastructure, much of it built before the threat of climate change was fully understood, is ill-equipped to withstand the fury of synchronized storms. We are talking about a whole new level of risk, says Dr. Kerry Emanuel, a professor of atmospheric science at MIT. The levees, the seawalls, the drainage systems, they were all designed with a certain set of assumptions in mind. But those assumptions are no longer valid. We need to start from scratch with a new understanding of what is possible. The task is urgent because the threat of synchronized cyclones is not a distant prospect. It is a clear and present danger. As the world continues to warm, the conditions that give rise to these storms are becoming more prevalent, more intense, and more widespread. Emmanuel warns that we are not talking about a future scenario. We are talking about a reality that is unfolding before our eyes, and the longer we wait to act, the more devastating the consequences will be. The fallout from the Madagascar double strike is not limited to the island nation itself. The ripple effects of the disaster are being felt around the world, as global supply chains, already strained by the COVID-19 pandemic, buckle under the weight of new disruptions. Madagascar, despite its relative obscurity on the global stage, plays a critical role in several key industries. The country is the world's leading supplier of vanilla, accounting for nearly 80% of global production. It is also a major exporter of nickel, cobalt, and graphite, all essential components in the manufacture of electric vehicle batteries. The destruction of the port of Toamasina, the main gateway for these exports, has sent shockwaves through the global economy. Vanilla prices, already high after a series of poor harvests, have skyrocketed, putting pressure on food manufacturers and consumers alike. The shortage of nickel and cobalt has raised fears of a slowdown in the transition to electric vehicles, a key pillar of the global fight against climate change. But the impacts of the Madagascar disaster go beyond the immediate economic fallout. The synchronized cyclones have exposed the fragility of the global food system, which relies on a complex web of trade routes and supply chains to feed a growing population. Dr. Molly Anderson, a professor of food studies at Middlebury College, says, "We built a system that is incredibly efficient but also incredibly vulnerable." When a key node in that system fails, as we have seen in Madagascar, the ripple effects can be felt around the world. The vulnerability is particularly acute in the developing world, where food insecurity is already a chronic problem. In Madagascar itself, the double strike has left nearly 500,000 people in need of urgent food assistance, according to the United Nations World Food Programme. The country is not alone. Across Africa, Asia, and Latin America, millions of small-scale farmers and rural communities are grappling with the impacts of climate change, from droughts and floods to pest infestations and crop failures. The prospect of synchronized cyclones, with their potential to disrupt trade routes and destroy infrastructure, only adds to that burden. Dr. Halsey Chambers, a climate scientist at the University of the West Indies, warns of a perfect storm of vulnerability. The communities that are most exposed to the impacts of climate change are also the ones that are least equipped to deal with them. And when you add in the threat of synchronized cyclones, the risks become almost unimaginable. The implications are not lost on the international community. In the wake of the Madagascar disaster, world leaders have pledged billions of dollars in aid and assistance, recognizing the urgent need to build resilience in the face of a new climate reality. But even as aid flows in, there is a growing recognition that the traditional approach to disaster response, a cycle of crisis and recovery, followed by a return to business as usual, is no longer sufficient. Experts say we need to move beyond the idea of simply managing disasters and start thinking about how we can prevent them from happening in the first place. Ariana Perez, a climate policy expert at the University of Buenos Aires, says that this means addressing the root causes of climate change, from deforestation and land degradation to the burning of fossil fuels. It is a daunting task, one that will require unprecedented cooperation and coordination at the global level. But as the world grapples with the fallout from the Madagascar double strike, there is a growing sense of urgency, a recognition that the time for action is running out. Perez warns that we are at a tipping point. The decisions we make in the next few years will determine the fate of generations to come. We have a choice. We can either continue down the path of destruction, or we can chart a new course that recognizes the interdependence of all life on this planet. As the world comes to terms with the new reality of synchronized cyclones, the question on everyone's mind is, what happens next? How do we prepare for a future in which the most devastating storms are no longer isolated events, but part of a larger pattern of destruction? The answer, experts say, lies in a combination of adaptation and mitigation. On the adaptation front, communities around the world are already taking steps to build resilience in the face of the new threat. In Bangladesh, for example, the government has launched a program to build climate-smart villages designed to withstand the impacts of cyclones and other extreme weather events. These villages feature a range of adaptations, from elevated homes and flood-resistant crops to community-based early warning systems and clear evacuation plans. The goal is to create a network of self-sufficient, resilient communities that can weather the storms of the future. Similar efforts are underway in other parts of the world, from the coastal cities of Europe to the island nations of the Pacific. But adaptation alone is not enough. To truly address the threat of synchronized cyclones, experts say we must also tackle the root causes of climate change. Dr. Samantha Becker, a climate scientist at the University of California, Berkeley, says adaptation is important, but it is not a substitute for mitigation. As long as we continue to pump greenhouse gases into the atmosphere, we are going to see more and more of these extreme weather events. The task of mitigation, of course, is a global one, requiring a coordinated effort from governments, businesses, and individuals around the world. But even as the international community grapples with the challenges of reducing emissions and transitioning to a low-carbon economy, there are signs of progress. In the wake of the Madagascar disaster, a coalition of nations led by the European Union and the United States has pledged to accelerate the transition to renewable energy, with the goal of achieving net zero emissions by 2050. The pledge, known as the Madagascar Compact, has been hailed as a major breakthrough in the fight against climate change. But even as the world takes steps to address the threat of synchronized cyclones, the reality is that the impacts of climate change are already being felt and will continue to be felt for generations to come. The question is not whether we will face more disasters like the one that struck Madagascar, but how we will respond when they inevitably occur. Dr. Maria Hernandez, a disaster management expert at the University of the Philippines, says we are entering a new era of risk. The old ways of thinking, the old ways of doing things are no longer sufficient. We need to be prepared for a future in which the unthinkable becomes inevitable. It is a sobering thought, but one that is increasingly difficult to ignore. As the world watches the people of Madagascar struggle to rebuild in the wake of the double strike, there is a growing sense of urgency, a recognition that the time for action is running out. Hernandez says we have a choice. We can either rise to the challenge and build a future that is more resilient, more sustainable, and more just, or we can continue down the path of destruction and face the consequences of our inaction. The choice is ours to make. Do not let the Madagascar double strike be your wake-up call. Subscribe now and like this video to stay one step ahead of the next coordinated climate catastrophe. In the age of synchronized storms, knowledge is your best defense. Join our community of prepared survivors and protect what matters most.